Hey guys, today I would like to show you some tips and tricks for scan to plan purposes in different kind of software.
At the current time, many companies work with 3D data and create intellectual BIM models, photorealistic meshes and digital twins, but even more still works with 2D drawings for different reasons. And unfortunately, there is no magic button that will create all materials for you, and a lot of work still should be done manually. Here you could find a video of that manual processing from my colleague Andy Fontana. But in this tutorial, I would like to show you some automatic and semi-automatic tools that could highly increase your productivity. Let's start from AutoCAD. Extract section lines from the point cloud. This tool creates lines or 2D polylines along the estimated intersection of the point cloud with the section plane. So the first step will be to create a section plane in any required direction. Select point cloud, choose the relevant section from the section tab and create it. Run the extract section lines from the point cloud tool. In the pop-up window, specify which lines you will need to extract. Only external contour or include all interior lines. Minimum line length parameters. The minimum segment length for lines and 2D polylines created. You can enter a value or specify 2 points on the screen. Connect line tolerance parameter. Connect endpoints or nearby extracted line segments when the distance is less than the specified value. You can enter a value or specify 2 points. Collinear angle tolerance parameter. Determine the maximum angular deviation before an extracted line or 2D polyline is separated into segments. A high value generally produces fewer and longer lines. This tool works well when you have a clean, unfurnished point cloud with the flat walls and all lines over half a meter, but in real life these conditions are rare. So in most cases you will get a lot of lines not joining each other and not relevant only to the walls. A similar tool you could meet in BricsCAD. It's named Project Section and it's located on the point cloud toolbar. First of all, you also need to create a section. You can create a single or multiple section, but you should use the detail section tool. Define the area and next input the height of the section and you will get some kind of limit box. Next, run the point cloud project section command. In the left pop-up settings menu, you should define gap parameter. Control the search area for the algorithm to draw lines. Gaps smaller than the specified value will be closed. Angular parameter. Control the angular tolerance of the generated lines. Height tolerance will result in pronounced right angles. This is useful for perpendicular plans. Generated lines with a smaller angle than the specified value will be merged. Minimum length parameter. Controls the minimum length of the generated lines. Lines with a smaller length than the specified value will not be generated. In both software, the result will be not perfect, and you will be forced to edit almost every line manually because you will need to delete redundant lines, close gaps, adjust corners, etc. In BricsCAD, you could try to do it automatically by Optimize button. The command makes corrections such as small gaps between lines or near vertical, horizontal and diagonal lines. But before running it, I recommend you left on the screen only lines relevant to one room because the tool analyzes all visible lines. After hiding unwanted lines, run this tool and specify angle, set the angle tolerance in degrees with respect to the world coordinate system. Near horizontal, vertical or diagonal lines within this angle tolerance will be optimized. Set the distance tolerance. Parallel lines within this distance will be merged. Set the gap tolerance. Gaps between collinear lines within the gap tolerance will be filled. Click Preview and you will see optimized lines. The combination of these tools could increase the speed of processing data by multiple times on some projects, but some of them will be not suitable for the tools. In this way, it will be better to use semi-automatic tools for extracting lines. You could find these tools in the CloudWorx plugin, but before using them, you should create a section in the desired place and use the Quick Slice tools. One of the easiest is the Quick Slice wall. It's based on an extracted plane from the wall. Just select it and click on any point on the wall. The software will change the coordinate system based on that wall and create a section at the particular specified point. Adjust the thickness of your section. Try to use thinner slices, then your drawing will be more accurate. Next, you have two options for fitting polylines into the section of point clouds directly on the main screen. 1 point polyline. Draw an auto-fit line string with a 1 point grow line segment. Each line segment expect one peak point and will region grow. To find the best next line for the point cloud. Each line segment will connect to the previous one as it is created. 2-point polyline. Draw an auto-fit line string with 2-point best fit line segments. Each line segment expects 2 points and will be adjusted to best fit the point cloud along the line. Each line segment will connect to the previous one as it is created. Following are all possible keywords. When you have flat walls with a clean point cloud, the one-point polyline tool could extract almost all contours of your section automatically. You could also change some settings for better result by clicking the Auto Fit Settings button. One similar tool which was added in 2022 version is floor plan creation. After creating the quick slice, click on the floor plan button to launch the tool. In the appeared window, you will be presented with a series of tools to help you create your floor plan. They are very similar to the previous tools, but in the floor plan window you can fit lines based on not only on point clouds, but also on auto-fitted lines. In the appeared window, adjust the left slider to define the best size and the position of your section. Click the Find Walls button and you will see a lot of lines on the screen. The result will be similar to auto-fit lines with the native AutoCAD and BricsCAD tools. Next, click the Construct Polyline button and connect line segments and fill in gaps to create polylines. Click on the red line segments or on the point cloud to connect them. They will become yellow. When you reach a gap, you can click on the wall automatically fit a line to the point cloud. Clicking on an area of point clouds and dragging will also try to create the best fit segments along the drawn line. Clicking and dragging from an area with no points will automatically create a line as a draw. Connected drawn segments will try to grow automatically if the Auto Advanced option is enabled, and will also refine as the new segments are connected or created. With enabled ortholine mode, all corners will be 90 degrees angle. After ending or closing the polyline, it will turn green. Green polylines may be selected and the endpoints can be adjusted to fine-tune your line work or to correct errors. Send to cut, push the finished polylines, shown as green lines, back to your current drawn model and closes the tool. Any remaining red line segment will be discarded and ignored. One of the main problems for all of these automatic tools is that they try to fit a straight line to the point cloud section, but sometimes the wall could not be flat, and the wall line should be represented with more than just 2 vertices. In this way, you can try to add more vertices to the polyline with the Insert P tool. Select the line which should be modified, select the increment option and specify the distance between vertices. Then run the Fit Section tool from the CloudWorx toolbar. The software will try to adjust each vertex to the section in the point cloud. The result will be not perfect, but it could save a lot of time anyway. If you need to add vertex manually, hover the mouse cursor over the middle snapping point of the line and click the A button on the keyboard. After all main walls will be finished, add doors and windows. I recommend using dynamic blocks for that. They are available in AutoCAD and BricsCAD. Dynamic blocks contain rules and restrictions that control the appearance and behavior of a block when it is inserted into a drawing or when it is later modified. You can add different visibilities, modes for blocks and rules for after alignment according to the polyline. Below you could download a small example of the dynamic blocks. If the majority of your work is creating similar 2D plans that contain only walls, floors and windows for space and elements calculating purposes, then look at the Point Fuse powered by Jetstream software. It's one of the easiest and fastest software that got tools for the classification point clouds. It allows you very fast to create walls and insert doors and windows and convert them to 3D models or 2D drawings. If you need to create a facade drawing with a lot of detail, in most cases you'll be forced to draw them manually, but you could use additional tips and tricks to faster the processing. Use different tools to change the coordinate system. You are always forced to change it because in all software the drawings are created perpendicular to the Z-axis. Use the orientation tools and the CloudWorx panel to easily place the UCS by the wall, by 2 points, by 2 walls and other methods. Save the UCS for easy and faster switching between them. Try different formats of the point cloud. All of them got different visibility modes. For RCP, try to edit the transparency of your cloud and enable normal scalar mode. It will highlight the main edges in the cloud. For LGS, try to use silhouette mode and change colorization by elevation. In the color settings, specify in which direction you want to color point cloud, the number of colors and steps between them. It will give you a better understanding of the depth of your elements. Use split screen mode for better understanding in which place you are generating section and creating drawings. Use ortho images. You can create them directly in CAD with CloudWorx plugin. Before generating the ortho image, left on the screen only relevant points and draw a rectangle around it. You could use it later for placement of your image. In the pop-up window, specify desired resolution and path for generating it. Try to generate ortho images with different color modes. Later you could combine them in the image editing software and get very interesting results. Now let's see what tools we can use in Cyclone 3D for scan-to-plan purposes. Similarly as in AutoCAD and BricsCAD, we can extract all lines from the section automatically. Select all the meshes or clouds on which you want to calculate sections and launch the planner section command. Define the axis for section, the position of section and the chaining distance. Click OK and you will see all extracted lines on each level. Close polylines with chain polyline and close polyline tools. Optimize extracted section with resample tool. This command allows you to resample polylines by choosing the desired number of points. For rectangular section that was not extracted perfectly, use the best rectangle tool to extract the perfect shape and convert it then to the polyline with the polyline from geometry tool. Also, you could use scan to plan. This command creates thin slices from a point cloud, which will be used to draw plans and elevation. The workflow is very similar to CloudWorx Flow Plan tool, so you can draw polylines manually, quick draw in a semi-automatic way, and use extract tool for automatic extraction. For extraction position of elements based on the wall, use the planar contour command. The command allows extracting planar contours from meshes and clouds. Segment manually extracted polylines to the rectangular and circle shapes. Use later extracted contours for placing the best circles and rectangles to them. Use best rectangle and best circle tools for that. And don't forget to choose to compute one shape per input to fit all objects together. Sometimes you could have a task to visualize any object that has a very complex shape, but the customer doesn't require too much accuracy. All that he wants just have an approximate drawings of the object to understand the main dimensions, for example. In that case, you could try a different combination of meshes and polylines. Let's have a look at a few examples. So the old forged metal fence, it has a lot of elements and all of them got the complex shape. First of all, try to clean the point cloud with the noise point cloud filter. Adjust the slider and the 3D will highlight the sparse points inside the cloud. Click the OK button and they will be automatically deleted. Create a simple plane object. You could use region grow, best fit commands or just draw it manually and convert it to the mesh with the mesh from geometry tool. Project point cloud to the mesh. Use the projection tool for that. For accurate polylines detection, we need to have a small size of triangles in the mesh, so you could use the subdivide tool in the preferences menu. For that tool, just specify the maximum edge of the triangle and click the OK button. Next, compare the point cloud and mesh to each other. Select the mesh as the object of colorization and then segment the mesh by inspection. Delete the non-fence part of the mesh and group the rest of the mesh. Now you can keep only the largest part and remove or hide all the rest. You can improve the borders of that mesh with the smooth border tool. It will give you a better shape of the polyline, or extract the polylines as it is with the extract all holes and borders tool and next smooth these polylines. This approach may not give ideal result, but it is not bad and suitable for a variety of tasks. The polyline can be easily exported to CAD and you can customize the final drawings as you wish. One more unusual example of using 3D for creating drawings based on the 3D mesh. It is extracting lines based on its slopes. Let's take the Victory sample as an example. You could find it in the samples folder that is installed with 3D by default, or you can download it by clicking the below link. Select point cloud and create the model with mesh in 2 steps method. You could use the same setting as I did. Define the view that you want to be used later in your CAD for creating final drawings. Let's set the front view. Segment visible triangles from all others. Use the manual clean separate tool for that and set only visible mode for selecting the triangles. Slope analysis creating based on the z-axis, so rotate the segmented mesh to be sure that its position is relevant to the top view, or change your coordinate system. Select the segmented mesh and click the Extract Polyline, all holes and borders. Next, smooth the extracted contour with the Smooth Polyline tool. Make the slope analysis and define color map as you wish. I'm trying to highlight areas that I want to be extracted. Extract some lines with the Localize Values tools and separate the analyzed mesh by the inspection steps. Extract all required polylines from the segmented meshes with the All Holes and Borders tool. Send all lines to AutoCAD with a single button. Don't forget that in Cyclone Studio you also could create high-resolution ortho images with different polarization modes and next blend them into any image editing software for getting the unique results. And remember, all above tools will not do all work for you, but they could significantly increase the speed of processing the data and make your life much easier.
I hope this video was helpful. Don't forget that all detailed information you could find in the description. For today that's all. Thanks for watching and see you next time.